Happy to be here. So today I'd like to share with you some of the research that we've done for the past few years, working with Fabian and also others collaborator and university in Vietnam. And we are focusing on a data platform that predict urban flooding in smart city. And this is the effort from University of Virginia, and also we have sponsorship from the U.S. National Science Foundation and the U.S. ASEAN Smart City Partnership. So these are some of the funding agencies that we have received funding from. And I just want to note that during the presentation, if you have questions, you can raise your hand, and I'll happy to talk about it. And if your questions are quite good, I might be able to give you some of the merchandise, the swag from the University of Virginia. So feel free to ask questions if something you want to talk about, discuss about. And of course, we're going to save some time at the end to talk about, some discussion item as well. But first, let me start by showing you this photo. So anyone see some familiar here? This photo actually taken from a French city. You know what city this is? North of France. Okay. And this is not recently, but take about a few years ago. And this is the city of Cote, which is about north of Boxville, I think, and taken in February 18, 2021. And you see there's a flooding, and this is caused by the river Charente, if I pronounce that correctly. That because of heavy rain, the river rise about 6 meters, and it's flooded the entire city. And there is the 1,200 people had to be evacuated. So this is one of the worker who's trying to evacuate people. And this is to show you that there's the worlds are getting angrier at us. The ecologies of the world are under stress, and even French are very low risk of natural disaster. Around the world, actually, people are having a lot of issues and threat with the natural disaster. So some of the data from the Institute of Economic and Peace that they recorded the number of natural disaster happened from the 1900 to recently. And you can see the trends are going up, especially after we kind of learning about it. And I think people are more aware of what's going on around them, and they can record natural disaster. But the number of disasters are raising for the past 100 years or so. And although, I think people are more aware of the natural disaster, there's a lot of countries at risk of resource, run out of fresh water, food, their overpopulation, and also experience more and more natural disaster like flood, drought, higher extreme weather and temperature. And so they did this analysis, and they about 1.2 billion in the world at risk of being displacement because of all of these things under the ecology. And in the US alone, US in the 1980 have about 387 climate-related disaster, where the total cost to mitigate this disaster is to the north of 2.7 trillion US dollar. And these are according to the data from the National Oceanic and Atmosphere Administration in the US. So that's around the world, and Vietnam also suffered much from this flooding. I grew up in Vietnam, and these are the images that I kind of grow up with. So this image right here is like on your way to work. When it was flooding, your motorbike will be, the engine will be flooded and it couldn't go. So you had to push the motorbike forward. And for students, it's just basically your bike had to do the same, and just water about your knee deep. If you go to a cafe shop, this is one of the cafe shop, you can't really sit on the ground, even on the chair. You had to put your legs up to, and it's very, if not inconvenient, it's also very hazardous because electricity and other things. And the third picture on the left is not what you think it is. It's not people trying to push a bus. It's actually a funeral. And that was the coffin with inside the funeral, and the people who pushed in the bus are actually having their funeral clothing. So you basically live with flood, you eat with flood, and even when you die, it's flooding. So it's become a way of life, but also, to have a more sustainable and smart future, I think we need a way to predict and alert flood early. And this is the reason why I'm interested in the project in the first place. I just want to see if I can contribute to help Vietnam from getting less affected by flooding, among other things. So how to predict and alert flood risk, right? The traditional method is to go talking on a megaphone or share it on a paper map or talking person to person. And nowadays, this is not scalable or sustainable. So we need to find a way to integrate all the data into a single digital map, and then that can be shared with people. And also, traditionally, if we're gonna build a hardware, software infrastructure, typically taking a lot of effort. But we notice everyone in Vietnam nowadays have smartphone with internet. So there's a need of having a common network platform that using different type of data put in together and can be communicate with their smart devices. And third, if you want to inject some of the predictive power so you can predict flood, it's going to require huge amount of data for training and also computing resource. So there is a need to have a AI enabled services that are scalable. So that's what I'm focused on solving these needs that happen in Vietnam and beyond. So the project, we call it FloodWatch.io. And this is sort of the overall overview of FloodWatch. So FloodWatch will stay in the center of the ecosystem, and it can communicate to different data source. And the data source come from IoT sensor, come from API, and even come from city manager. And that could be available to all different citizen users, and also for the city manager or analysts or people who want to model the flood. And some of the application can be built from FloodWatch, so that you build some scenario that can help people evacuate or finding way to alert people when the case of flood. So the FloodWatch.io is a IoT infrastructure that can handle and support multiple networking protocol, including LoRaWAN and others. And it have AI built in, so you can actually plug in your AI model to assess and predict flood and forecasting flood. And finally, it's also a map-based network platform that user can use to share flooding event. Think about it, it's at a crowdsourced sort of platform as well. So now it is an international collaboration, and I'm very fortunate to work with Professor Fabian Federal here from University Cote d'Ivoire, and then a couple of faculty members from the Vietnam National University in Ho Chi Minh City, and also a faculty from the University of Da Nang. And on the US side, I have my colleague Ta and Ron Hutchin, who is in the investigator of the grants. And this, again, is the work supported by the National Science Foundation and the USAID Smart City Program. And I cannot discount the work done by my student, my research and development team, because they done most of the work. To taking a lot of credit for it. But the current student have a lot of industry experience. So they're working at companies like Netflix, Meta, Facebook, Amazon Web Service, and CoStar. And we have, show our work at notable conference, ACM KDD, IEEE Big Data, and Triple AI workshop. And another thing that I really enjoy about this project is many of our alum turn out to be very successful and working for notable company like Microsoft, Amazon, Adobe, Verizon, and Zoom. So credit to a lot of these students that working with me. Some of them actually also attending a PhD program at prestigious university. But so today, I like to share with you 3 things about FloodWatch that potentially we can ignite some collaboration. Is about the data platform. So at its core, FloodWatch is a data platform. So it takes data from IoT sensing. It's going to make data available for AI services. And it's also make the data available and shared by citizens. So I'm going to address each and every of these items. So again, feel free to raise your hand if you have questions. I'll happy to answer it if it's confusing. All right, so let's talk about data from IoT sensing. So you can start with IoT sensor. So you have a network of IoT sensor, and these sensors not necessarily just from your group, but from a lot of different research groups. So all of these considered an IoT sensor, and through some gateway or API, it's gonna get access, to our server. And this one we take many data from third party, but we also build our own sensor in collaboration with our partners. And from the network server, this is where all the data is stored, and that's where you can plug in different AI algorithm trying to train and trying to make prediction. And after that, the data are going to be compiled into interactive region-based map or tile set. And the tile set is going to be available for the user on the apps. And FloodWatch app, the way I think about it, it's just one app. And if you want to create multiple apps, you can actually plug in with our map module as well to create different type of apps here. So we work to make sure that if you get access to the app, you get all the aggregated data from all of these weather sensors. And we have piloted this data infrastructure in multiple countries, so including Vietnam, US. I just added France because we actually, since I here a couple of weeks, we actually deploy more sensor in France, which is really cool. And we have some collaborator in Germany as well. We help our collaborator to share the data, the part that they can control to share, and they can also keep the data for publication and other services as well. So some of the dashboard that we built that's help data manager, sensor manager to manage their device. So you see one of the setting here is on mobile device. You can see this is in Germany actually, and this had multiple locations that they install the sensor, and you can monitor the status of your devices and how well-being your device, where it is, whether it's functional, how much data is sent to it over there. It's really tiny text. Over here is the number of data is sent per 24 hours. And some of the really nice feature is if your device is down, we actually having a protocol to communicate with the device manager through email. So they can say, oh, your device is low in battery, or your device offline, or I don't know, a bird had knocked your device over, something like that. So we have that functionality for managing the sensor. And also, we built our own sensor as well. So this is the work from Fabian Group. You guys recognize this place, this rooftop. So a few days ago, we deployed some of our own sensor on the rooftop. And this is what we call the low range sensor. And it's look like this, the low range sensor. What it does is gonna measure several things that including temperature, humidity, and also rainfall. I'm gonna look like this little box, but like rainfall will be falling on the top, and it basically have a little hole here collecting the rain, and it have a mechanism where the weather, if the rain come down, it's gonna fill this bucket, and it's gonna flip if the water exceed a certain threshold. So every time it flip, it counts at the in the sensor, and this also have a little magnet here, so it would activate the sensor and wake up the sensor, so the sensor would be start listening to these rain. And inside we have a chip developed by Fabian Group, and it's operated by 2 AAA batteries, so it's low cost, and it's also lasts pretty long time. I think Fabian can attest to it, how power sufficient it is. And inside the chip, we have We also have some building sensor for temperatures and humidity, and also a little counter for number of time the magnet move across, so we can measure the rain as well. So I'm gonna show you, and this is actually one of the first LoRaWAN applications that we deploy in Vietnam. And let me show you on the FloodWatch of, I think I'm gonna pass this around so you can view it for yourself. Pretty durable. It maybe has Fabian to help me, put this back. Okay. And feel free to pass it around so you can see it. I have another one right here, actually transmits data in real time. So this is the O2. So if you go to the FloodWatch, so we have a website, this one here. We actually can go to France right now. And a couple of days ago, Fabian put that onto the roof. So we're gonna go visit it in the. So we are narrowing down to this building, right? Update my location here. So I think this is it. So this had been transmitting data in a few days ago. Yeah. And you can see the last time it transmitted data is 219. I think it is 221 right now. So just so it's almost real time. These devices are, this one is actually onto the roof. So you can see right now it's pretty hot out there, I guess, because the sun reflects the glass. So it's about almost 40 degrees out there. So, and if you look at humidity, it's also measured humidity for the past few days, up and down, pretty nice. And also the rain, you notice rain in a few days. So we actually captured some of the rain as well on the roof, and you can measure how much rain it got. And good thing, because I know here is barely rain. So I get kind of lucky that a few days that we install the sensor started raining.
This year has been very rainy.
So yeah, we got some rain coming from the sensor as well. And these sensors can be programmed to send data in some period, right? So that is our Lorraine sensor, and we'll go pass this around so you can see it as well. So next is the data after we collected data from all these sensors is going to use for AI services. Let me move this somewhere. Okay, I'll move it over here. Okay. So in order to build any meaningful predictive model, we need to collect a lot of data. So we take some effort to obtain historical data from multiple sources, including data of humidity, precipitation, which is rainfall, wind, temperature, elevation, and tidal volume. It's, tide rise up and down of 65 major cities in Vietnam for a period about a decade long. So we can have a lot of data point, and also watching the trend that happened the last 10 years in Vietnam. And we also collecting recent flood events by scraping the new report and the UN Office of Coordinations and Humanitarian Affairs. So we have about 210 flood events that we can use to train our machine learning model. So out of these, we use a combined long short-term memory LSTM model combined with a deep neural network and predictive model. And this actually can be plugged in. So if you come up with better model, it can easily to plug in this framework so that you can make a good prediction. And most of our data are stored on the cloud. So we're using Amazon AWS to run all of these services. And if you're interested in learning about how we actually make predictions, I'll show you a quick supervised learning approach that we use. So basically, our data is time series. And so we get tidal information, and precipitation information, and we can feed that in to train a LSTM for a 24 to 48 hour periods, depend on when the flood. So we can look backward 48 hours, and we can see this time series. And also, beside time series, we also take into more individual features, just like elevation and the acceleration of precipitation. And that's going to train on a separate deep neural net with normalizations and ReLU activation. And the label that we use is the normalized ratio of people who affected by the flood and the population of the region. And that get to calculate at the flood severity. So we can use that to train the network. And you know, since we don't have a lot of flooding data, I mean, you have a lot of non-flooding data, but that's usually not as useful when, so we try to focus on when the flood comes, right, which is pretty rare events. In fact, we are looking at ways so that we can detect flood at anomalies, which become a more self-supervised method, which it doesn't require a lot of label data. But for this particular paper, we were using a supervised method. So simple architectures, and certainly, you know, it worked well for our purpose, but I think we can improve it in the future as well. And then finally, we have a voting algorithm to combine the result of these two networks to provide a severity score. So what I'm going to do now is that after we predict these severity, it's a single data point, right, for a certain city. The problem with this approach is if you start plotting different points, the city, it would look something like this, and it's not sufficient. And let me tell you why. If you plot data points, what happens is you only cover whatever regions that you have the data, but other regions will be blank. So some of the city, some of the regions that have low population or don't have enough data, they are completely underrepresented. So they don't know what they have, right? So that approach provides no value for the residing citizen. And also, if you plot a lot of points on the map, it's going to get very crowded and reduce the utility of the platform. So we take an approach of converting data point to geospatial regions. So our approach is we taking lots of weather reading across Vietnam. So you can think about it over the geographic region of Vietnam. We take 20,000 weather readings on sort of scattered. And these are from either from weather stations that are available and share the data, or third-party APIs that are available. But this can be spread across Vietnam to get the weather reading. And from the weather reading, we now can cluster different data point into region features. And so you can see here, different data point here now can be clustered into these bounding regions. And then the centroid and also the average reading of each region can be extracted. So now our prediction or flood prediction are region-based. And better yet, not only region-based, is multi-hierarchy regions. So you saw different country is organized in administrative region. So you have the province, and then you have maybe the city district, and then you have maybe lower neighborhood level. These are called ward in Vietnam. So 3 different regions can be predicted with precisions. So what I'm going to show you guys now is how it's making prediction on these regions. And if you want, you can actually test this out right now as well on your phones or on the link to the website. It is live. We have daily prediction on the flood in Vietnam. Our scripts are run nightly, so it's always up to date. Right? So if you want to check it out, it's FloodWatch.io, or you can just scan the IQ QR codes here. But I'm gonna go to the FloodWatch.io now to go to Vietnam from Nice. Over here. So you see our maps, the entire world. Am I going too far? Okay, not. All right. So here it is, Vietnam, and this is today. So I'm going to move this down a little bit. So you can see we have a little calendar icons here. So this is today. And what important is that you want to look at prediction, right? So you want to move this little sensor to the next tomorrow, which is 22nd in Vietnam. And here's you can see the returns is a flood map in a sense. And if you can look at, you say, okay, this region look like there's some trouble going on, or it predicted going to be some high risk of flood tomorrow, and you can investigate. So you can zoom in a little bit here. So this is a Lam Dam region in Vietnam, and it can predict about 49% chance of floods that happening. And this is based on the factor that I was mentioned. But if you say, okay, I see this region in trouble, if I zoom in a little bit more, now going to break to the next geographic or administrative region. So you can see some of the region now is a part of the provinces. So these now become district. And you can see that on multiple district. And if you're interested in zooming more, you can actually zoom into a very small region here. So these are, you can think about it's a ward or a neighborhood kind of region. So it's smaller, more precise, but also has some reading. So apparently there's a lot of raining tomorrow in this ward, and the flood risk about 52%. Now, I'm not saying this is 100% accurate, because our prediction is as good as the weather prediction, because that's where our data come from. And I think there's definitely room in the future for us to make a better prediction algorithms, having better architectures, and incorporate even more feature and model. But I think what's important here is that we provide a platform where things can be plugged in to make it work. Right? Oh, we have a question from Lionel. Go ahead.
Hi, yeah. I was wondering, like, do you use also satellite images as the data sources or only the IoT devices?
So, very good question. Do we use satellite images? We have planned to use satellite images. In fact, one of our features is elevation. So the elevation is taken from the Google Earth, and it takes into account, what the elevation, the regions. We have considered use satellite images, but it's also difficult to acquire these satellite images in real time. We have talked to NASA to see if we can acquire some of the satellite images, but it is a very exciting also, look at the elevations and also the terrains of the two to do. So that's a great idea. Yeah.
Yeah, you could also talk to ESA, of course. The European Space Agency is providing a lot of stuff in a very
exactly.
open access way.
Okay, he's raising his hand right now, so that's good timing. Okay.
Which is
Okay, I have not heard of that, but that sounds like something we should look into. Okay, thank you.
Maybe you can mention that you have been working on this.
Are you working on that right now? Okay. Okay, very cool, very cool. So you have detail of the river maps, basically. That
Seeking for solution.
okay,
Not prediction.
that's very good. I think it's very relevant too, because we actually also look at the polluted water body in Vietnam as well, because there's a lot of pollution being pushing out from rivers and oceans. So that's definitely two sides of the same coin. Very good. Thank you. Good. So we got some overlapping here. All right. But anyway, so this prediction can help city manager. So you imagine if you want to provide some evacuation plan or allocate resources to a certain region of the provinces or city, this map could be very helpful to those city manager. And of course, right now we provide forecast up to 4 or 5 days. And of course, when you go further out, it's become less accurate, but this is available as well as part of our API. They can make prediction for about 4 or 5 days into the future. Pretty much this. All right, so let me go back to presentation, and I'm going to show you the third point about the FloodWatch platform is about sharing data to the citizen. So the idea that I was very interested in is how do we raise more awareness of the citizen? Of course, our technology can be great, but if the citizen not interested, nobody going to use that, right? So the idea here is what called technological citizenship. So it's a live and crowdsourced report that contribute by the citizens that make them more engaged, make them empowered to share this at the benefit of their neighbors and their community. And I believe this might be, if we done this correctly, it might lead to a new form of civic involvement. The way that people can feel like they are communicate and they are part of their community and make them more empowered because they get access to these tools, right? So what we built at the pilot phase, we built a multimodal data sharing. So they can share the rating. So here you see they can set the rating of the flood. So and then put in some of their comments to share. And they can share the location of the flood on the map. And also if they take a photo with their phone, they can also show the picture of a flood. Right? And then you can submit to the platform that way. Now, when you do to data sharing here, you also open the floodgate. You heard of the expression open the floodgate? It's when all the data pouring in and you don't know which one is good. It could be all garbage, right? And it's very popular at social media because a lot of people posting also misleading, incorrect information about these images. So the question, the research question that we look at is how do we know these shared images are appropriate and useful for our prediction model, right? So now we need to use image information. How do we know it's actually useful, right? And how do we know it's real as well, right? So we look in this for a little while and we come up with a way to validate these flood images. So for example, any user can take a picture of the flood and upload to the platform, and they can use that to share the data. So what we're gonna do is we build a convoluted neural networks, convolutional neural network to make prediction whether this image is a flood image or not. So we look at the content of the image. So if you post an image of a, I don't know, a street that dry, we're gonna reject it from the server because that's obviously not a flood image. So we look at the content image to determine this is whether it actually have body of water in there or not. And we train this separately using images from the Google Images of flood image and non-flood image. So this is basically a very high accurate problem, and it's been used in the technology. But our innovation is that we also combine this content of this image with additional information. So what those information is weather information. So these are real-time weather. We find the real-time weather while the image is uploaded. Sometimes you can allocate the time and also the place of the image so you can get weather data, right? So how is it useful here? Is that if the weather indicate that it's no rain and your image have rains on it, we know it's not either taken at the different location or it's just a random image, right? So you can use these extra bit of information to validate the upload of the image. And recently, we also look into additional information like, whether you have a nearby sensor and what sensor reading at that location. So that can corroborate to the user upload. So this is a very nice pipeline that using different model of information to validate each other, to cross-validate each other. And then if the the weather validate the flood image, then we would accept the image into our platform and use that as training image. So that's what we kind of provide a solution to validate the image. And this is actually won an outstanding paper awards a couple years ago. And UVA liked this idea so much that they provide a U.S. Provisional U.S. patent to give a patent to this approach. And I think I'm actually working on filing it this summer. And finally, with the rise of recent ChatGPT and large language model, we were thinking how we can make this useful for FloodWatch user. And so we have a NLP for enhanced interaction, and this is the work in progress. So imagine you can talk to FloodWatch. So instead of zooming around the map, and you can just give it command, right? You can say, hey, what is the flood risk in Da Nang tomorrow? And so we're gonna need to look into how the user interact with FloodWatch. And we have this NLP request for information here that take into tokens, different bit information the user was asking, and extract things like locations and dates, and then use that as input to one of our API. So this can be multiple services that we use that we can extract information from. And we also, forward the question into a large language model here. And from there, it can provide some really natural language response, right? And this is an example of what it would say, right? So it would say, Da Nang have low flood risk, night temperature, and you should go to the beach, right? At the same time, because we know these information about time and location, we also can manipulate the map. So think about it like you would have the world, and you can pan and zoom into the specific location that you find, and also move the predicted slider so that would just go on the right location. So we can combine the power of large language model with some, map manipulation API, right? So this is a elevated user experience because they can now ask them questions. And if you are a city manager, you want to move really fast, and this is a good way for you to get the information you need without navigating the map. And it's actually helped me because I'm pretty bad with geography. So if you ask me to zoom into some city, I couldn't do it. I'm some city, I don't know where it is, right? Especially if it's in Germany or somewhere I'm not familiar with. But this actually, helped a lot with that navigation. And as everything trying to done on real time. And also we are running some user study right now. But this have very promising is that the user would gain more insight by just interact directly using natural language with the FloodWatch. So if you're interested in something like this, we're actually working on a paper submission right now to get this published. Okay, so in summary, I'm sharing with you FloodWatch, which is a data platform. And we have data from IoT sensing, data for AI services, and also data shared by citizens. So these are the core functionality of FloodWatch. And some of the future direction that we are thinking about, we want to make FloodWatch a warning system for natural disaster. Right now we build an API so that the FloodWatch can provide useful information for other platforms, other apps. We have a working API. We shared it with Da Nang City. We try to install and register more remote sensing devices. So if you're working on some remote sensing devices and you feel like this is necessary, it can be deployed and it can be registered in our platform, and you can be manager for those devices. Again, flood is just one of the many natural disasters. So we plan to extend FloodWatch into detecting drought, wildfires, which is a big deal in the US, and also pollution, air pollution, water pollution, and so on. Definitely the trend right now is trying to figure out a way to inject federated learning to learn and do detection on embedded hardware, and while maintaining a foundational model. So that's also a very interesting direction that we are very interested in explore in the future. And also, evolve FloodWatch to become a bit more multiple sensing IoT application. Maybe it will become Smart City Watch. I don't know if you got the reference City Watch. I'm a big Game of Thrones fan, but I know you heard. Anyway, so how can we collaborate with University Cote d'Azur? So I have 3 questions about research, whether we can submit joint proposal for scientific or technology innovation between Cote d'Azur and University of Virginia to organize some research and development. And I'm currently exploring with Professor Farrell, but hopefully, we can get, a nice proposal going on to keep our effort moving forward. About engagement, I'm certainly very interested in creating an environment for citizens to be more active and engaged and make a positive impact on people's life. And students or citizen alike, the big question is, how do you make people more interested in helping others? And finally, if I say education, I want to explore what sort of protocol or procedure needed to organize an exchange program in CS or IoT, and then train workforce for both US and France. So these are the questions that I hope to get answered this summer. And so if you have interested, we certainly should discuss it. And also I have a few facts about University of Virginia, so that you can carry away with. Is we are the number 3. Actually, I had to say this because I work for them. We are number 3 ranked public university in United States. We are number 1 computer science program in the state of Virginia. This is where I get all my good students. Also number 1 research university in Virginia, and about 572 million euro in annual research budget. And funded by multiple agencies here. We have 9 Nobel laureate, 8 NASA astronauts, 8 Pulitzer winner, 30 government of the US states, and 55 Rhodes Scholar. And our alum also find very successful company like Reddit, CNET, the Weather Channel, Space Adventure, and Skillshare. So if you want to collaborate or visit University of Virginia, we're very welcoming. And one more interesting fact of Virginia is the architecture of universities are heavily influenced by Thomas Jefferson's visit to France when he was US ambassador in France. So a lot of architecture you see at University of Virginia is example of French architectures.
It's also that he visited Nice when he was in France.
Oh, you
You know,
it's well.
the museum does all the way. I mean, Jefferson was going all the place he was going, and basically he go to Nice, and he was also going to town to Turin and so on. So
Great. So I found that's a nice connection. So thank you very much, and I appreciate it. Yeah, thank you. So I want you to ask me a question because I need to give these things away.
So why do you develop a specific sensor? Because you have many data through the Weather Channel, through the all the national weather organization. They have very dense, also providing humidity, wind, and so on. So why did you develop specific sensor?
So, so we believe these sensor eventually will be put into the hand of the citizens.
Oh,
But right now, the Weather Channel, it's by weather station.
yeah.
And it's very broad. I think some city might have 1 or 2 weather stations. So it's very not provide a fine readings of what the weather's going on. This is why the Weather Channel say it's a 55 chance of raining, because they actually don't know where it's gonna rain. And in fact, some areas not raining at all, where the larger area.
Put on specific locations.
Correct. So these sensors are location specific, and we want to build this low cost, so we can put into citizens' hands, and they can have this very specific reading for their location and their neighborhood.
So I have another question, because there is IEEE, there is a site, the single interest group for humanitarian technologies. They are very, very interested by all kind of low-cost system for alerting people of disaster or something like that. Site. IEEE site, yeah.
Okay, definitely. I'll take notes and.
I'm part of this.
Oh, you are? Okay, so I talked to the right person. Would you like a map to put any wall?
Yeah, it is awesome. Thank you.
Yeah. Okay. More questions, please.
Thank you.
Yep. Yes.
That one, it's slightly related. I was wondering, who was at the beginning of your idea the target of your product? Because if you are giving it to the people that you are jumping to governmental activity,
Right.
sensor, sensing, and everything. So are you in contact with them, with the entities that do this only for the sake of training, or even for
Great
telling
question.
them, okay, that's the danger, and then that
Right.
the other. Because right now we have their system work relatively well.
Mhm.
Maybe they're quite late. So side question,
Okay.
how fast is the system? Danger,
Okay.
the
Very good question. Actually, I have the two questions, so I'll address one at a time. So number one question that you have is, who is the contact in the local government that you, so when I say we give it to citizens, we don't directly go and give it to people, right? We work with the local governments, and specifically the city of Da Nang, where we piloting our study. We work with the local governments. So we basically give them the sensor and then say, you know, you want to give it to your leader of the ward or the district. And so they are managing our device. We don't actually manage these sensors. So I think the point is very well taken, is that we need collaboration from the local government. We can't really manage this ourselves.
How many sensors can you provide? Remember that?
How many can we replicate it? I think it's a matter of also, you know, different phase of research. Because right now it's you know, it's still in research phase, and we just want to run some small tests. But you know, the point is we can make these reasonable, that we can have it on high volume. You know,
How the
replicate
cost
it.
for the problem?
I think right now it costs about $12 to build, but this is small number. So I think if we scale it to large numbers, it probably drive the cost down even more, but about $12 US. Okay, so second question, I'm sorry.
Yes.
Second question is about the how fast is prediction? Okay.
No, I
Accurate, yes.
And now how accurate? Oh man, I'm gonna need to give you two big things, because this is very good question. So how fast is it? So we run all the predictions at midnight. So you get 20,000 data points from the weather's readings, and at midnight we run, and it basically a few seconds to get all the prediction. Sometimes the data running on hourly, so you can make predictions hourly, but these depends on how often you want to run this prediction. So fast, I think is really fast. You can make, and besides the prediction can make way in advance, so you can see prediction for tomorrow, then the next day. So people get alert pretty quickly. How accurate this is? I don't think it is accurate enough to make it a widely used platform at the moment. And for the reason that we need to get more training data. We need to incorporate physical data. So hydrology model, they've been studying this thing for a really long time. Right now, we look in ways so that we can build hybrid model. So we incorporate the physical and the hydraulical model, so the water runaway models and the river tides. So all of them need to be incorporated. Right now, the system are purely data driven.
AI can help with that.
I certainly, you know, AI is my hammer. I like to.
I don't see everything that can be incorporated in the AI question that you have.
Sure. Sure. I guess the question is, you know, we need to get more collaboration from the hydrological community to get the appropriate training data for our work. Most of our data come from, you know, the hydrology and weather station, but like expert provided data, we've been lacking. So that's certainly room for improvement, I would say. And I think that's where it's exciting, because if you solve the problem already, there's nothing to work with. So I think we still have a way to go. The nice thing is that we build our platform so that it's easy to be modular. So you want to have a better model, you can just easily plug it in for that. Would you like to choose?
yeah. So I think question.
Okay, okay. I have really nice like shot glasses, like espresso glasses, right? Sorry. Yeah. Okay.
Here in this, there is just a little roads and it's actually good now, so
Mm.
that's how do you give that percentage of
Right.
the race?
Right. Very, very good questions. Flood severity is a very objective um, uh, measure. So think about it, it's like in Virginia, which is we got snow maybe once a year, and when we have snow, everybody panic, right? But if you are from Illinois or some Michigan on the north, oh, they just pow to the snow. For them, it's no problem. So it depends on you know the occurrences of flood, and also the severity basically based on you know how many people affected by it, right? So people feel like I don't affect it. I just like 2 inches of flood, no problem. Then you know severity is low. But some other region that means oh my God, we had to shut down the school, right? So we looking at this severity at from like new reports and things like how many people affected by it, and then we normalize it by the ratio of the population. So it might be different from region to region. Of course, right now we just focus on Vietnam, but I mean other regions might have different tolerance of flood. And this also lead to a really interesting point that every region should have its own predictive model. So if you go that route, you go down to every sensor should have its own predictive model depending on where it's coverage. And so the idea of having more federated learning kind of techniques also matter when you want to predict on multiple regions and multiple countries, which have very different data and very different expectations. Yeah.
Yeah. I propose to stop the webinar now, but whatever, we have a coffee open, so if you want to continue the discussion, you can stay in the room and discuss directly with Rich. So thanks a lot.
Thank you.